Hello and welcome back. In this video we're going to discuss the OR statement. I have one set up right here. Before we do that, just want to go over a couple things. One, here's our OR statement, which we call a disjunction. And OR statements are compound statements. They are made up by combining simple logical statements. So here's one, Washington, D.C. is a state. And then we have another simple statement here, presidential elections are held every 4 years. Now each one of these we're going to call components. Now remember, components will help determine the truth value of our OR statement, but don't confuse the overall truth value of an OR statement with the truth values of the components. So let me read off this statement one more time. Washington, D.C. is a state, or presidential elections are held every 4 years. Okay, so if we take a look at the truth values of the components, let's take a look at the first one. Washington, D.C. is a state. We know that one to be false. And presidential elections are held every 4 years. We know this one to be true. So what are the rules that help determine the truth values of the overall OR statement? So we have a disjunction is true, so our OR statement is true when at least one component is true. So just taking a look at the above statement here, the overall OR statement is true. Even though that one of the components is false, this one specifically, the OR statement as a whole is true. So if a disjunction is true when at least one component is true, what does it have to be, or what do the components have to be in order for the OR statement to be false? A disjunction is false when all of its components are false. Sort of similar to an AND statement, where an AND statement is true when everything has to be true. A disjunction, or an OR statement, is false when all of its components are false. So again, the above statement up here is true. But unlike an AND statement, where it's pretty cut and dry, the OR statement, we actually have two different versions of an OR statement. Our two different OR versions are called exclusive and inclusive. Now, we use both of these ORs every day. We are sometimes used to the inclusive OR, but let's go over both. Sorry, I mean that the one that we tend to use in everyday usage would be the exclusive OR. So what I'm going to do is I'm going to give you two examples, one of an exclusive, one of an inclusive, and we'll take a look at the difference between the two. So let's take a look at our example for the exclusive OR. So our statement is Tim can order soup or salad. Now you've probably heard this type of statement before, where you can order soup or salad, and usually what it means is that you can have one, the soup, or you can have the salad, but you may not have both. And that's going to be the difference between the exclusive and inclusive. As in an inclusive, you might have one to be true, you can have the other one to be true, so soup could be true, meaning you order soup. You can have salad, but you may not have both. So to quickly sum up the exclusive OR, it could be true when one component or the other are true, but you cannot have both to be true. Now if you take a look at our inclusive, here's a statement. Lance brings pencils or markers to class every day. Now, is it possible for Lance to bring both? Is there any reason why he can't bring both? And no, he can bring pencils or markers to class every day, and there's no violation of this statement if he brings both. So again, the difference between exclusive and inclusive is when are you allowed to be both? So exclusive, you can't have both. Inclusive, you can bring both. So to summarize the inclusive, you are allowed to have one component to be true, the other component could be true, makes the entire OR statement true, or you can have both to be true, and it still would make the entire OR statement true. So when trying to determine the overall truth value of your OR statement, like the one that we have up here, what you're going to do is you're going to look at each component, determine the truth values of each component, and then follow the rules. So just like with the AND statement, we did make a truth table. For the AND statement. Let's quickly do one for an OR statement. Now you might have asked yourself, well, which one do we use? Do we use the exclusive or do we use the inclusive? And when talking about logical statements, so not like sentences or statements we say out every day, but statements that we're going to be assigning truth values to, we always use the inclusive. It just makes things easier when we don't have to exclude that whole both scenario. It just makes things easier when we are allowed to have both be true. So when dealing with logic, we are doing the inclusive. So you'll see that down in the truth table here. So we have two statements, P and Q. Now when P is true and Q is true, then P or Q will also be true. It satisfies our statement above where an OR statement will be true when all of the components are true. Because remember, in order for an OR statement to be true, just one of them has to be true. And because we have both, it's definitely true. Alright, now if you have P to be true but Q to be false, it still makes a true OR statement because one of them is true. And then P could be false, Q could be true, which makes it true. Now the only time an OR statement is false, when both components are false, and that will make the overall OR statement false.